Hello guys, welcome back to Maths African Motives. In this platform, we shall be focusing on polynomials for A-level mathematics. So actually, there are questions that we are going to consider or work with. But before that, I just want you guys to have a basic understanding of polynomials, which is one of the most important things that you must have before attempting these typical questions. Okay, let me just do this for the meantime. All right, so that's what we are having for this class. All right, so just gonna have it aside here. What I want you to understand, guys, for the polynomials is that okay, we've got polynomials here. If you are given a function, because here you'll be actually working with functions, function of x, or it can be function of y, any function that you be given. All right. So what I actually want you to understand is that if you are given y, which is equivalent to f of x, y is representing f of x. Okay. We can have a factor that affects the function of x. When I'm referring to a function of x, I'm just referring to something like f of x is equivalent to ax squared plus bx plus c, or we can just have another function, maybe it's gx, which is equivalent to ax to the exponent of 3, bx to the exponent of 2, plus cx plus d, something like that. All right. These are functions that you are referring to. So for any function that you might be given, there is a factor. They can be a factor or they cannot be a factor at all. Okay, so that leads us to what we are okay, so this is actually given. So this leads us to what we refer to as a factor and remainder theorem. Factor and remainder theorem, which is one of the most important parts that you're supposed to understand before attempting these typical questions. A factor to a function of f of x. Let's say we are given that x plus a is a factor. Okay, it is taken from, okay, so let's start with the factor theorem. The factor theorem. Okay, so from the factor theorem, if we are given this condition, if f of a is equivalent to 0. Okay, let's say you substituted a in place of x in the function of x, then you obtain a 0. Therefore, x minus a is a factor. Okay, so it's a factor of f of x. This is what is important, guys. Take note. If you substitute a, x minus a is a factor. If a gives you a 0, if you substitute a on f of x, then you substitute any number, you obtain a 0. X minus a is a factor. So take note what I'm trying to say here. If you substitute 3, okay? So if I'm saying if f of 3 is equal to 0, what does it mean? Therefore, x minus 3 is a factor. That is what you're going to have. Take note, you substituted 3, but on a factor, it's now minus 3. So that means if I am having f of minus 2, which gives me a 0, therefore the factor here is going to be x minus minus 2, which is x plus 2, is a factor of what? F of x. So all these, they are factors of f of x. If you substitute such a condition, okay. But if you substitute now a certain value, then you do not obtain a 0. That means it's not a factor. That part is actually giving you a remainder. You are obtaining a remainder from there. Okay, so this actually leads us to a consideration where you are going to factorize certain expressions. By factorizing, then also you have got the long division part, which is going to come out from this procedure. Actually, you'll be dealing with a cubic expression. Take note, quadratic, guys. You did quadratic expressions when you were in O-level math. When you're doing O-level math, you were dealing with a quadratic where you are given to factorize. So you'll be given considerations now to factorize completely. All right, so you can actually factorize the given questions completely. let's just take this one. It's given as, okay, let me just start with the basic question, basic. Then we move on to those other typical questions. X cubed plus x squared minus 4x minus 4. Okay, this is a cubic expression. The cubic part is from the highest exponent, which is 3, okay? If it was from x squared up to this part, the highest exponent, it's now a quadratic, the one that you were used to when you're doing O-level math. But now the highest exponent you'll be dealing with 3. Okay, let's say you're given a consideration for you to factorize this completely. There are actually so many ways that you're going to consider the long division part, or you can use the other one, which is called synthetic division. I'm going to explain those methods. Then you take the one that is used in your syllabus. Okay, let's say you want to find the factors here, because you definitely need to find the first factor. From the first factor, then you can find other factors. Okay, so the first factor is the tricky one, and you must be very, very careful. Okay, for you to find the first factor, you use this concept that we talked about, that if you substitute a certain number, then you obtain a 0. Therefore, x minus that number, it becomes a factor. Okay, so that's the concept that you're going to do. So you are supposed to try the numbers. And these numbers that you are trying to substitute, you don't just substitute, okay, let me substitute when x is equal to 20. Let me substitute when x is equal to 10. No. You don't do that. Okay, you are going to focus with the constant term of the expression that you're given here. And our constant is minus 4. So you focus or you work with minus 4. What are the factors of minus 4? Okay, factors of minus 4, it can be plus or minus 4. Okay, it can be plus or minus 2. It can be plus or minus 1. These are factors for the numbers that when you divide here, you obtain an exact value. So what you do is that you try these numbers to substitute them into this expression. Then from there, you can obtain the first factor. So it depends with what someone actually tried to substitute. Okay, let's start with 1 here. I'm going to work with plus 1. Okay, so if we are working with plus 1, therefore we are going to write this as f of 1 is equivalent to, we substitute 1 into f of x. This is your f of x, this expression. So what you're going to do is to substitute 1 into this expression. So if I substitute 1, this is 1 to the exponent of 3 plus 1 to the exponent of 2 minus 4 times 1 minus 4, like this. Okay, so this is what you're going to obtain. So you can actually use your calculator to prove the exact value. Okay, so let me just enable my calculator here. So let me share the whole of the screen. Okay, so that we can see the calculator. All right, so this is what you're going to do here. We substituted 1, and 1 to the exponent of 3, guys, is just 1. Okay, but we are going to write this so that when we are substituting other values, there's no need for us to rewrite this again. Okay, so this is 1 to the exponent of 2 minus 4 times 1 minus 4, like this. Okay, so if you substitute, you're going to obtain minus 6. So in this case, we are obtaining minus 6. That means this is not a factor. Because we are supposed to obtain a 0 if it is a factor. So you try minus 1. Remember, we tried positive 1. Now we try to substitute minus 1. So it is going to be minus 1 to the exponent of 3 plus minus 1 to the exponent of 2, 4 into minus 1, sorry, minus 4, like this. Okay, so let's just substitute. So here on our calculator, we are just putting a negative here. So it's minus 1 here. You move on, you put minus 1 here, you move on, you put minus 1 here. Okay, this gives us a 0. So our answer here is a 0. So if you substitute minus 1 and you obtain a 0 like this, it means therefore x plus 1 is a factor. Take note, guys, here. Remember what I said. If you substitute a, you obtain a 0. X minus a is a factor. If you substitute minus 2, x plus 2 becomes a factor. Okay, so that's what you're actually having. We substituted minus 1, then we got a 0. So x plus 1, you simply introduce minus, so it will be x minus minus 1, like this. which gives you x plus 1. So with this factor of x plus 1, what are we going to do now? Remember, the question is for you to factorize completely. All right. So this part now is the one that is going to lead us to the long division now. Okay, so what are we going to do, guys, with our long division? Okay, this is what you're going to do. We obtained the first factor, which was x plus 1. So with the first factor of x plus 1, you divide it into this. Okay, why are we dividing? Okay, let me give you this basic part. Let's say you are dealing with 6. 2 is a factor of 6. If you divide 6 divided by 2, you obtain 3. 3 is also a factor. That's the concept. So it means if x plus 1 is a factor and we divide it into this expression, whatever that we are going to get or whatever that you're going to obtain, it becomes also a factor, just like what we did. 6 divided by 2 is equal to 3. 3 is also a factor of 6. So the long division way is the one that I'm going to use here. So using long division. So guys, be very, very careful with this one, long division. So on your long division, you're going to divide x plus 1 into this expression. So it's going to be like this, x plus 1 into the whole of this expression, which is x to the exponent of 3 plus x squared minus 4x minus 4. So that's your long division. So I'm going to show you the steps that you take when you are dividing here. Okay, so these are the stages or the steps that you're going to take, guys. You are going to divide the first term versus the first term, the first term versus first term. So it's x cubed versus the first term here, which is x. So you divide x cubed, divide by x. So that's the first part that you do. You divide x cubed, divide by x, guys. This is x squared, okay? So we are going to obtain x squared. You write it on top. Whatever that you obtain here, you multiply back to the whole expression, which is of x plus 1. So it's like this, x squared multiplied to x plus 1, like this. So whatever that you get, you multiply to everything, okay? And the answer that you obtain by multiplying, you write it down now. So it's x squared times x, which is x cubed. X squared times 1, which is x squared. Okay, so we have multiplied. So we divided, we multiply back. Then after multiplying back, you subtract. So guys, don't be confused. Divide, multiply back, subtract. Okay, so now we are going to subtract x cubed minus x cubed. That's a 0. Okay, that's it. That's a 0. That's a 0 there. Okay, x squared minus x squared, that's a 0 again. So which means here we are obtaining a 0, here we are obtaining a 0. There's nothing that you're going to get here. So what are you going to do? You drop the numbers that are remaining. You are remaining with minus 4x. Here we are remaining with minus 4. You drop them down. After dropping these numbers down, that means we are going to redo the stages that we did before. What are the stages? The one that we divided x cubed and x. So now you are at this expression, which is minus 4x and minus 4. So that's where you are now. So you are going to divide back. So it's the first term always versus when you are dividing, guys, first term versus first term. So it's now minus 4x divided by x. So as you can see, this can cancel, you obtain negative 4. So that means we are going to have negative 4 on top here. Okay. Remember, guys, what we did previously when we got x squared. When we got x squared, we multiplied back. So it's the same thing with minus 4. Minus 4 is going to multiply back everything here. So you multiply minus 4 into x plus 1 like this. Minus 4 into x plus 1, which is minus 4 times x, which is minus 4x. You write it down. Remember, when you multiply, you write it down. Minus 4 times 1, which is minus 4. Okay, so this is where we are now. And after writing this down, what have we done in the first procedure? We subtracted the numbers. So we are going to subtract, just like the previous case that we did, we are going to subtract. Okay, so if we subtract, what are we going to obtain? Clearly, here we can see that minus 4 and these are the same. So if you subtract, that's a 0. Minus 4 and minus 4, they are the same. So if you subtract, that's a 0. And we do not have any number that is left here that we are going to drop down. We do not have anything. So that means we are done dividing. If you do not obtain, take note, guys, if on this last part here, you do not obtain a 0, let's say you obtain 5, or you obtain 7, or you obtain any number, that means you are wrong. If this was a factor, then you are wrong. Because this can only happen when the expression that you are dividing with is not a factor. That's where you obtain a certain number, like a 5 or any other number. And that number, it represents what is called the remainder. So take note about this. If you divide, you obtain a certain number which is not exact, which is not 0, then know that your division is wrong. If you said x plus 1 is a factor, it must give you a 0 here. Okay. Anyways, guys, let's see what you're going to have at the end. After we are done dividing, actually, we have divided, we obtained a 0. Therefore, what is the next stage? Because someone is asking, what are we going to do now with this whole part of division that we did? Okay, remember the question was for you to factorize. And when we started here, we said x plus 1 is a factor here. Okay, remember what I told you? If you divide the number by its factor, you obtain a factor. So when we divided this expression by x plus 1, we obtained x squared minus 4, the one that is on the top. This is your answer. So it means it's a factor also. So x plus 1 is a factor, x squared minus 4 is a factor. But what's the relationship between these two factors? Let me explain from these two numbers. 2, when multiplied to 3, it must give us a 6. Take note, guys. 2 and 3 are factors. These are factors. Okay, so if you multiply these factors, they must give you a 6. So it simply means, guys, if we are to take this into consideration, it simply means this whole expression that we had of x cubed plus x squared minus 4x minus 4, it is equal to the first factor that we obtained, which is x plus 1, times the other factor that we obtained, and the other factor that we obtained is x squared minus 4. A factor multiplied to another factor from the division, it gives you the original number that we had, or the expression. So that's what we have. So it simply means, guys, if we are to factorize x cubed into this, all this is going to give us x plus 1 into x squared minus 4. But remember, you are factorizing completely, and from your O-level mathematics, you can tell that x squared minus 4 is a difference of 2 squares. So this is going to give us the square root of x squared, which is x, the square root of 4, which is 2. So one bracket adds and another bracket subtracts. So this is the final answer that you're going to have after factorizing this whole expression. We are going to obtain x plus 1 into x plus 2 into x minus 3. So that is what we refer to as the long division, if you apply the long division. But there is a synthetic division that I'm going to explain in another class, so that maybe you can understand other ways that you can use, which is not, but for ZIMSEC, it's actually good for you to use long division, because those guys from department, they actually know the long division. The synthetic, I'm going to explain it later on, but that's how you actually factorize. Okay, so a remainder now, if it is a condition where you have a remainder, the number that you substitute, like let's say you are given f of x, okay? Given f of x. Then if you substitute, like let's say if f of 1 is equal to 7, let's say you substituted 1 into this expression, then you obtain a 7. This 7 is actually a remainder, okay? It's actually a remainder. That's the remainder theorem. So it's actually nothing there. So I'm going to explain this consideration now using the questions that we are given. Right, so these are the questions that we actually had from the beginning that we said we are going to focus with. Okay, So these are actually from the previous exam papers. I just forgot to write the name, the actual name of the paper. These are from past exam papers. On number 10, we're given that the polynomials f of x is equivalent to 2x cubed plus 7x squared plus ax plus b, and gx is x cubed plus ax squared minus 5x plus 2b. We have a common factor. So take note, x plus 3 is a common factor. Find the value of A and the value of B for marks. B, the common factor, the second common factor. All right. So it's actually a very, very typical type of a question, and it's very, very important for you to understand how to work out these typical questions. Okay. So what I'm going to do is to rewrite the expressions that we are given for f of x and for gx. All right, so that we can see how we're supposed to answer this one. Remember, we are given that, so this is actually number 10. We are given that f of x is given as 2x to the exponent of 3 plus 7x squared plus ax plus b. Okay, and g of x is given as x to the exponent of 3 plus ax squared minus 5x plus 2b, like that. Okay. Then x plus 3 is a common factor for these two. X plus 3 is a common factor. Okay, we are told that this is a factor. All right. All right, all right. Okay, so x plus 3 is a common factor. So remember, guys, what I told you about a factor. Besides being common, just being a factor. Remember what I told you. It means that if you are to substitute, remember, x plus 3 is a factor. So it means that f of minus 3, this is a factor. So minus 3 is supposed to give you a 0. That's where it was actually taken from. Remember what I said? F of a, if it is equal to 0, it means x minus a is a factor. Okay, x minus a will be a factor. So if it is minus here, therefore a factor must be a positive. If it was x minus 3, then here it was supposed to be f of 3. But it's a common factor, which means it's a factor to f of x. It's a factor also to gx. So also g of minus 3 must be equal to 0 also, just like f of minus 3. If it is equal to 0, therefore the same thing with the g of minus 3, it must be equal to 0. So now with this, it can be an advantage because you are just substituting for f of minus 3 to be equal to 0. That means in place of x, I'm just going to substitute minus 3. So it's going to be 2 into minus 3 cubed plus 7 into minus 3 squared. Then here it's ax, but our x is minus 3, so it's going to be minus 3a plus b is equal to a 0. Simple like that. Okay, so we can simplify, but here we are not going to waste much time because what you're going to actually do is to just simplify this part. Okay, where is my calculator? All right, let me just try and do this. Okay, what you're going to do is just simplify where there is now this part and this part, because here there is a and b, so you can't simplify that part. Okay, so that's 2 into negative 3 cubed. Okay, that's negative 3 cubed. Okay, plus 7. Okay, so you're gonna have plus 7 into minus 3 to the exponent of 2. So this is minus 3 to the exponent of 2, and that's going to give us 9. So here we are going to be left with 9 minus 3a plus b, which is equal to 0. So it's actually an equation that you can have. So you can just say this is our first equation. Okay, so just leave it like that. We'll see later on. We move on to g of minus 3. If we are given that g of minus 3 is supposed to give us 0, then it's the same thing. In place of x, in g of x, we're going to substitute minus 3. So it's going to be minus 3 to the exponent of 3. This is ax squared. So we are going to have plus minus 3 squared a. Okay, then minus 5x, which is minus 5 times x, which is minus 3, plus 2b plus 2b. This must be equal to 0. So that is the consideration. Okay, so we can actually simplify the numbers separately. And the numbers that we are referring to in this case is this minus 3 to the exponent of 3 and the minus 5 times the minus 3. These are the only numbers that we have which are direct. So minus 3 to the exponent of 3, whatever that we get, we subtract minus 5 into minus 3. Okay, so that's minus 5 into minus 3 like this, which is going to give us negative 12. So this is negative 12. Okay, then minus 3 squared, that's positive 9. So it's going to be positive 9a plus 2b is equal to 0, which is the second equation. So what can we see? What can we say? These are simultaneous equations. So you're now back to your O-level mathematics. I don't know which method is best for you to solve these typical equations, but we have got two equations that we are supposed to solve now to obtain the value of A and to obtain the value of B. So I'm just going to write these equations separately here. All right. So from the first equation, I can just try to make B to be the subject. I'm just going to use substitution method. So I don't know which method is good for you, but I'm just going to use substitution method. Okay, so you choose the one, either elimination by substitution. I don't know which one is best for you. Okay, so use the substitution method. I'm going to make B to be the subject of the formula. So B is equivalent to a transpose 3a, negative 3a is going to be positive 3a, 9 to this side is going to be negative 9. Okay, on the other hand, I'm given this equation as it is. So I have to substitute this because I'm now having equation 3. So I'm going to substitute equation 3 into equation 2. Okay, so you substitute into the other equation, not the first one, because that's where you made B to be the subject. So you substitute into equation 3 in place of B. So in place of B, if we are to substitute this part, we are going to remain with negative 12 plus 9a plus 2b. 2b, this is your b, which is 3a minus 9. So you're going to have 3a minus 9 is equal to 0. So that's what you're going to have. So you can solve for a. Then after that, we substitute here to find the value of b. So prove with another method to see if you're obtaining same values, guys. Okay, minus 12 plus 9a, 2 times 3, that's 6a. Okay, 2 by 9, that's negative 18 is equal to 0. So you can collect like terms. That's 15a, negative 12, negative 18, that's something like negative 30. So you're going to obtain negative 30. Then we transpose to the other side of the equation, which is going to be positive 30, if I'm not mistaken. All right, so divide by 15 here. A is going to be equivalent to 2. So we have got the value of A, which is 2. So to find B, we are going to simply substitute in any of these equations. So you can even substitute on this one, since already B is equal to 3a minus 9 from equation 3. So you can just substitute the value of A, which is 3 times A, which is 2 minus 9. So B is equivalent 3 times 2, which is 6 minus 9. So B is equivalent to negative 3. So that's it. So you've got the value of A and the value of B, which is minus 3. All right, so that was the question actually from this part. But take note, the other part of the question is now find the second common factor, and that's 3 marks. Okay, what you're going to do in this case, okay, let me just have it down here. Remember the values of A, guys, do not forget. On part A, we got A, which was equal to 2, and B was equal to minus 3. Okay. So what you're going to do to find the common factor, you can actually substitute the values of A into the given functions, f of x. Let's rewrite, guys, so that we can see these properly. Okay, so that's the B part. So remember, f of x was given as 2x. I'm just going to adjust. That's 2x squared, 2x cubed plus 7x, then A, it's 2, so it's going to be 2x. So you just substitute there. So that's going to be 2x cubed plus 7x squared. Okay, I have some other stuff here. Let me just try and erase. Sorry for that, guys. I didn't actually erase when I was using those examples. Okay, so we had 2x to the exponent of 3 plus 7 of x squared, and it was ax, and our a is 2, so it's going to be 2x and b, which is minus 3. All right, so this is your f of x. Then gx, you do the same. You write your gx, you substitute a and b. So if we substitute the value of a and the value of b, this is going to be x cubed. b, a is 2, which is 2x squared. Then b here is 2 times minus 3, which is minus 6. All right, so our gx can be written as x cubed plus 2x squared minus 5x minus 6 after substituting the value of a and b. Okay, so these are the expressions that you are given, which we can properly see. And the question was for us to find the other common factor. So this is what you're going to do. Remember, for you to obtain a factor, guys, you are supposed to have this consideration where I said f of a, if it is equal to 0, therefore x minus a is a factor. But this is supposed to be common between these numbers. So on f of x, for you to find the factors, remember I told you, for you to find a factor, you consider or you work with the common term, with the constant term, which is minus 3. Okay, so factors of minus 3, we've got plus or minus 1, plus or minus 3. These are factors of 3. Okay, we move on to gx. We consider our constant, which is minus 6. What are the factors of minus 6? We've got plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. So as we can see, since it is a common factor, there is no way I am going to try to substitute 2 because I do not have 2 on the factors of 3 here. It's supposed to be common. So actually, plus or minus 2 is going to be out. Plus or minus 6 is going to be out. Plus or minus 1 we have got here. Plus or minus 1 we've got here. Plus or minus 3 we've got here. Plus or minus 3 we have got it here. So you are going to try and substitute a number that gives you a 0 on both functions. So what am I trying to say? If you substitute, let's just say I choose to substitute 1, okay? It must give us a 0 on both expressions. Okay, so try to substitute and see which one is giving you a 0 on both functions, either f of x or g of x. But as for me, and also do not substitute the values the first factor that you're given. Remember, we are given the first factor previously. Don't substitute that one. Okay, so let's try. What I'm trying to say is that you can just try and substitute 1. Okay. When x is equal to 1, let's see. If you substitute 1 by just looking, is 2 plus 7, which is 9. 9 plus 2, which is 11. 11 minus 3 cannot give us a 0, so which means 1 is actually out. When x is equivalent to minus 1, let's see f of minus 1, what are you going to have? Okay, if you substitute 2, this is going to be minus 2 plus 7, which is 5. And this is going to be minus 2, which is minus 2 minus 3, which is minus 5. So it's 5 minus 5, that's a 0 here. So this is going to give us a 0, okay? G of minus 1, we do the same. This is minus 1 plus 2, which is 1. Then 1 plus 5, actually, both this is going to be a positive. Okay, so this is going to be 1 plus, which is 6. Then 6 minus 6, that's a 0. So this gives us a 0. So you can just substitute on your calculator, guys. It's fine, but you can actually see by side. So as you can see, if you substitute minus 1 on F, you obtain a 0. If you substitute minus 1 on G, we obtain a 0. So that means, therefore, x plus 1 is a common factor, is a factor. Is also a common factor. Okay, so remember, if you have got minus 1, a factor, you introduce minus. So it's minus minus, which is going to be plus 1. So x plus 1 was another factor that you were going to obtain from these two. So there are so many ways you can actually try to do the long division way. If you apply the long division, yes, you can win by that one, but it's going to be something that is, there's a lot that you're going to have from there if you are to apply the long division. But these are the typical questions actually that you can have. So you must be very, very careful when answering these typical questions. That is what is important. Okay. On number 6, we got number 6 here. Okay, sorry for that. I'm just gonna remove this part. Okay. this page. Okay, so let me just remove this part alone. Number 6, we are given that given x plus 2 and 2x minus 1 are factors of this expression. Find the value of a and the value of b. So this one is similar to that one that we had previously, but now we only have one function, which is f of x, which is equivalent to 2x cubed plus ax squared plus bx plus 6. So let's start with x plus 2. Okay, so if x plus 2 is a factor, okay, so if x plus 2 is a factor, therefore it means f of minus 2 must be equal to 0. So that's it. Remember, you introduce a minus, so f of minus 2 must be equal to 0. So all you can do is that you equate this. X plus 2 is a factor, so x plus 2 should be equal to 0, so x is equal to minus 2. So you substitute when x is minus 2. Okay, so that's it. So let's substitute when x is minus 2. We are going to have 2 into minus 2 to the exponent of 3 plus this will be minus 2 to the exponent of 2a. This is b times x, which is our x is minus 2, so it's going to be minus 2b plus 6 is equal to 0. So that's what we simply mean when we say f of minus 2 is equal to 0. All right, so we can just simplify from our calculator and see what you're going to have from the numbers. So from the numbers, we've got 2 into minus 2 to the exponent of 3. Whatever that we get, we add 6, because these are the only numbers that we have. So we add 6 here, which is negative 10. So we've got negative 10 from this part. So negative 10 minus 4 squared. Okay, minus 2 squared actually here is 4. So this is going to be 4a minus 2b is equal to 0. So we've got an equation that we have. But from this equation, since it is an equation, you can actually try to reduce it out. So you can just reduce by 2, by 2, by 2. As you can see that 2 is common throughout. So 2 into negative 10, that's negative 5. 2 into 4, that's positive 8. 2 into minus 2, that's minus b, which is equal to 0. Okay, so this is when x plus 2 is a factor. Okay, so we move on to the other consideration. Again, we do the same thing for this one of 2x minus 1. Okay, so they say 2x minus 1 is also a factor. So we can actually do the same thing. Okay, okay, so let me just write it this way, the same way. So if 2x minus 1, okay, so if 2x minus 1 is a factor, okay, so therefore it's f of what, which is going to give us a 0. That's the question. Okay, so on this one, it can be tricky part, but it's not tricky, guys. What you simply need, equate this to 0. Okay, 2x minus 1 is equal to 0. So minus 1 to this side is going to be plus 1. So 2x is going to be equal to 1 divided by 2 by 2. So x is equal to a half. So it means f of a half must be equal to 0. So you're going to substitute x, which is equal to half, in place of x here. So it's going to be 2 into a half to the exponent of 3 plus a half to the exponent of 2 times a plus bx, which is plus half b plus 6 is equal to 0. So that's it. All right, so just like the previous part that we had, all you need is to simplify this part from your calculator. So just a matter of changing these values. All right, so let's just see what we are going to have here. All right, so we are going to just substitute a half here. That's what you're going to do. From this one, that's a half, which is 1 over 2. Okay, so if I'm to substitute 1 over 2, I'm going to obtain 25 over 4. So this will be 25 over 4. Half to the exponent of 2, that's 1 over 4. So this is going to be 1 over 4a. Okay, plus half b plus half b. Remember, we simplified this one and this one together. So this is going to give us a 0. All right, so that's another equation. But from this equation, guys, we can try to get rid of these fractions. Okay, so this was our equation 1. Let's try to get rid of the fraction. We can just multiply by 4 each and every number so that we can get rid of the fraction. That's our LCM, which is 4 times 4 times 4 times 4. Okay, so we can actually have 4 and 4 can cancel, that's 25. 4 and 4 can cancel, that's plus a. 2 into 4, that's 2. So it's going to be plus 2b is equal to 0. So we have got the second equation. So just like what we did from the previous part, when you've got simultaneous equations, you can use substitution, elimination. I do not know which method is best for you guys. For that one, I do not know. Okay, so as for me, I'm just going to apply the substitution method again, or elimination. Let me just try to use elimination this time. So since we used substitution last time, so this is going to be 2a minus b. I transpose 5 to the other side, minus 5, which is going to be positive 5. Okay, you have got a plus b. So this is a plus 2b, sorry, which is equivalent. I transpose 25 to the other side, which is negative 25. So remember that when you are eliminating, you are supposed to make sure that these two are the same. So you can just multiply by 2 on top, or by 1 on top, then by 2 below. So this is going to be 1 times any number. Remember, it remains as it is. So it's going to be 2a minus b is equal to 5. 2 by a, that's 2a. 2 by 2, that's 4b, okay? Which is equivalent to 2 by negative 25, that's negative 50. Okay, so this is negative 50. All right. So if multiplied by 2, so to eliminate, we can simply subtract the second equation from the first equation. So what we obtain if we subtract here is 2a minus 2a, that's a 0, minus b minus 4b, that's minus 5b. So minus 5b is equal to 5 minus 50. Take note, 5 minus 50, that's 5 plus 50, which is 55. So divide by negative 5 by negative 5, b is going to be equivalent to negative 11. All right, so I have the value of b, which is equivalent to negative 11. So to find the value of a, I can just substitute into any of these equations that I'm having here. A plus 2b. Okay, let me just use the easier one on top there, 2a. Okay, 2a minus b. 2a minus b is equal to 5. Remember, b is minus 11, so it's going to be 2a minus 11 is equal to 5. So 2a is equivalent to minus and minus. That's going to be a positive. So if we transfer to this side, it will be a negative. It's going to be 5 minus 11. And what is 5 minus 11? That's going to be a 6. Okay, so that's negative 6 actually. So divide by 2 by 2, a is going to be equivalent to minus 3. Okay, so we've got the value of a, which is minus 3, b, which is minus 11. So that's what you actually needed from this question. Okay, it was a lot. Okay, so the question was for you to find the value of a and b, 5 marks. Hence, find the third factor. Okay, hence find the third factor. Okay, so here I'm wondering, 2 marks, why 2 marks? Okay, anyways, it's fine. So remember that we obtained that a is minus 3 and b is minus 11. I just want to remove this part so that we can work with our question clearly. Okay, so remember the values, guys. Do not forget these values. Okay, so what I'm going to do is to rewrite this f of x. Now substituting the values of a, so it's going to be 2x cubed. Remember, a was minus 3, so it's going to be minus 3x squared, and b was minus 11, so it's going to be minus 11x plus 6. Okay, we already have 2 factors that we are given. Remember what I told you guys about a factor. If you divide the whole expression by a certain factor, you also obtain a factor. So since we are given 2 factors here, we can do it the longer way, whereby you can multiply the 2, then you do the long division. Okay, or you can simply work with the constant. Remember what I told you to find a factor, guys. You work with the constant term, which is 6. What are the factors of 6? Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. But of all these factors, there's no need for you to try this one of x plus 2, which is of x, which is minus 2. So you try other values and see which one is going to give you a 0. You try 1, you try minus 1, you try 3 minus 3, you try 6 minus 6. One of these must give you a 0 if you substitute. And from when I tried this, it was actually positive 3. F of 3. Okay, let's try to substitute f of 3. This is 2 into 3 cubed minus 3 into 3 squared minus 11 into 3 plus 6. Okay, so that's, let's see, that's going to be 2 into 3 to the exponent of 3. Okay, minus 3 into 3 to the exponent of 2. Minus 11 into 3, minus 11 into 3 plus 6, like this, that's a 0. So as you can see, f of 3 gives us a 0. So if f of 3 is equal to 0, therefore x minus 3 is a factor. So take note, guys, what I said about a factor. X minus 3 becomes a factor. Okay, so that was the easiest way. Maybe it's enough for 2 marks. If not like that, you can try to do the longer way. And what's the longer way? The longer way, you have to multiply the 2. Okay, let me just do the longer way. Or we could have done this way. We could have done this way. Since these are factors, x plus 2 is a factor, 2x minus 1 is a factor. You can simply multiply these two factors, combine it to combine these two. So you can combine this, that's 2x squared, x and 1, that's minus x, 2 and 2x, that's 4x. Okay, 2 and minus 1, that's minus 2. So it's going to be 2x squared minus x plus 4, that's going to be 3. So you're going to have positive 3x minus 2. So it means this is a combined factor that you're going to have. Remember, this is a cubic expression. So if you divide a cubic expression by a quadratic expression, you obtain a linear expression. Remember that, guys. You're going to obtain a linear expression. So what you're going to do now is to apply your long division. You are dividing 2x squared plus 3x minus 2 into the whole of this expression, which is 2x to the exponent of 3 minus 3x squared minus 11x plus 6. So you're now back on that long division that I explained it before. So remember what I said, guys, when you are dividing, it's always first term versus first term. So 2x cubed divide by 2x squared, 2x cubed divide by 2x squared. So this is going to cancel x squared into this, that's x. Guys, from your O-level maths, you can tell this. So you're going to obtain x. And whatever that you get, you multiply back to everything that you see here. All right, so let's multiply back and see what you're going to have. X times 2x squared, that's 2x cubed. X times 3x, that's 3x squared. X times minus 2, that's minus 2x. Okay, so from this part, we are going to subtract. Okay, remember after multiplying back, you subtract. So if you are to subtract here, 2x cubed minus 2x cubed, that's a 0. Minus 3 minus 3. Minus 3 minus 3, that's minus 6x squared. We move on to minus 11 minus minus 2. So it's minus 11x minus minus 2x, which is going to be a plus. And we know that minus 11 plus 2, that's negative 9. So this is going to be negative 9x. Okay, then we are remaining with 6. Remember, the remaining number, we have to drop it down. So you just drop that number, that's a plus 6. So that's what you obtained after you have subtracted, then you drop down the number that you're given. Okay, so this is what you're having now. You divide back just like what we did. Minus 6x squared divided to the first term always. So it's now minus 6x squared divided by 2x squared. Okay, x squared and x squared cancel. 2 into negative 6, that's negative 3. So we are going to obtain negative 3. Then we multiply back. Negative 3 multiplies 2, that's negative 6x squared. Negative 3 by 3, that's negative 9x. Negative 3 by negative 2, that's positive 6. And whatever that you obtain after, we subtract. As you can see, the first expression and the second expression are the same. So if you subtract like 5 minus 5, that's a 0. So these two expressions simply gives us a 0. So that means the final factor that we need is x plus 3, which is the same as the one that we obtained here, which is x minus 3. So these are the typical questions that you can actually have, or that you can actually be given if you're dealing with polynomials. So we shall work with more questions for guys from Maths on African Motives. Make sure that you subscribe to my channel, and also to share our videos to your friends and colleagues, so that they also can benefit from this information that we are having. More to come, more videos to come. If there are some other questions that you're having, you can consider sending your questions on the comment section. Make sure that you also be part of our maths group, so that you can send your questions there, so that we can work those questions together. From Maths on African Motives on A-level mathematics, till we meet again.